In this part of the assignment, we will interpolate precipitation with influence of topography. So in the first part, we will switch the region because we will be interpolating precipitation for the entire North Carolina. And notice that we will be setting first the horizontal spatial extent to the raster elevation that is statewide at 500-meter resolution. So you can see we have resolution of 500 meters and our spatial extent covers entire North Carolina. And we can zoom to computational region and you can see that it has, the rectangle has changed quite a bit. And let's remove this legend. Because we will be incorporating also the elevation into the interpolation, we will set also the third dimension of the region. And it will have only one depth because we will be not computing a voxel model, but we will be just computing a cross-section through this voxel model. So the output will be just two-dimensional. And please listen to the lecture and go through the slides for more in-depth explanation how this works. Also, you can find the explanation in the manual page. So we will be limiting our computation to North Carolina boundaries. So let's see whether we have such a raster map. So it's this NC mask 500 meters. So we will use this raster as a mask. Once we have the mask set up, all the computation is done only in the masked area. Now we will be using the precipitation points, precipitation stations for interpolation. So let's look at what kind of variables we have there. So as you can see, for each station, we have latitude, longitude, and we have also the elevation for each station. And then we have 30-year average monthly precipitation for January through December, but also annual precipitation averaged over 30 years. So let's look at where those stations are. So you can see that they are distributed along the over the entire state of North Carolina, with a little bit more sites near the mountains where we have much greater variability in precipitation. So first we will use the bivariate interpolation to compute the precipitation map. And let's just use or assign a custom color table for the precipitation that we have downloaded in the first part. And I will just display it again. And let's look at the legend. And we can move the legend closer to the map. And what you can see that the driest and the wettest periods are really in the mountains of North Carolina. And actually this very dry spot here is around Asheville, and that's the area that was hit by remnants of Hurricane Helene over the past week. So you can see how different and how unusual this event was, because this is essentially over the considering the 30-year average precipitation, the driest location in North Carolina. But very close to that, we also have the wettest location. So that's where all that rainfall usually falls. The problem with bivariate interpolation is that this doesn't take into account the elevation, so the low precipitation spreads all the way into the mountains. And you could see that if you look at the images in the lecture, which also include the topography. And you can include topography as a shaded topography, or you can drape this output over the three-dimensional view of North Carolina elevation, if you would like to. But for the report, this will be enough. So let's just save this image. And now we will use trivariate spline interpolation to incorporate the elevation information, elevation data at each station, along with the digital elevation model, to refine our interpolation of precipitation. So we already looked at the variables, so we can just double check the names of the variables that we will be interpolating. And as you can see, we will be interpolating as input, we use the points, the stations, precipitation stations. Then we also use as input the digital elevation model that is statewide, so that we can incorporate it in the output, in the computation of output. And then the output will be the precipitation with the influence of topography. We are computing it, it's all masked, so we are computing it only for the masked area. And we are also tuning the influence of topography with this parameter z-scale. And with the SegMax 700, we are essentially allowing it not to use segmentation and use all the points for the computation of the interpolation function. And we have only 160 points or so. So 136 actually. Okay, so this is the output. So let's just change the colors to our custom color table. And you can clearly see now the difference in the mountains. So throughout in these areas, which have very little topography, the outputs are very similar, but there is a significant difference in in the spatial distribution of precipitation in the mountains, where the dry area really shrinks, and we still have quite large precipitation in the mountains. So we can save this map for the report. So now when you are finished with this interpolation, we will remove the mask, so that when we are doing more work in the following assignments, we are not restricted by this mask. Okay, so don't forget to answer the question, and you can use the manual page for vSurf RST and vVol RST, as well as the lectures to help you answer the question.